Presentation, I just want to review the three rules that we already have: arrow out, ampersand in, and ampersand out, and then introduce wedge in. The first rule we learned was arrow out. Now remember I was using squares and circles, and so here is the basic rule for arrow out. And our basic proof, P arrow Q, P therefore Q. We prove it, first listing our two assumptions here. And then because we have our left side here in the assumption 2, and we got conditional in the first line of our proof, we can take the left side, toss it into the conditional, and free up the right side. So again, why I use squares and circles to give you these rules is because if we made this something that looked a little bit more complicated, say this, the same rule would apply in just the same way. It would just look a little bit different. But we still have our left side here in 2 that goes into our conditional statement there, and we would still kick out the same thing. So remember, we're matching the left side of the arrow because the arrow is the main operator here. And if we have the left side of the arrow, we can just go ahead and write the right side of the arrow, and we would cite our conditional statement, our antecedent, or our left side, and then cite our rule, arrow out, and look for the two assumptions that are going there. So sorry if I had 1 written there before. Obviously that's a 2 because that's another assumption. But that is our basic rule for arrow out. Our basic rule for, our rule for ampersand in is to say that we have 2 different things, and then we can introduce an ampersand between them. We can write it like that, or we can write it like that. Doesn't matter the arrangement that we have. Just says that as long as we have 2 separate things, we can put them together with an ampersand on either side. So simple proof again. P, Q, therefore P and Q. So we would list our assumptions first, associate them with the line numbers they appear, and then from these, we can just put them together. Ampersand in, 1 and 2. So this P is like our left side here. This Q is like our right side there. And again, if we were looking to prove the opposite, so say that, we would just do the same proof, just rearrange them in order. Just like that. And just to show you a complication on this, just like I did on the previous one, say if we were looking to prove P and Q as one premise, P arrow T is another premise, and we're looking to write P and Q and P arrow T. Well, our premises would be our first 2 lines like the previous one. Assumption, 1 and 2. And then we would just put them in the order that they need to go in based on our conclusion. That'd be 1 and 2, ampersand in, 1 and 2. So here we get the left side, here we get the left side. Here's our right side. And then when we're just putting them together, we just put the pieces to fit the way our conclusion is telling us to put them. So that's ampersand in. Now, ampersand out is just the opposite of what we just did. We go from a conjunction, and then we can write either side of it. So say if we had P and Q, and we were looking to write P, we would just take our one premise here, and we could just separate it out using our and out rule, and that would be all that we would need. And so this would be like my square. This would be like my circle. I don't do anything with my circle. That's okay. Say if I was wanting to do Q instead. Same exact proof, just different result. And just to stay consistent here, let's do a little bit more of a one that looks a little bit more difficult, but is the exact same as that, which would be, let's say P and Q. And P arrow T, just like last time. Let's say we just want to write P arrow T. Well, then our one assumption will go here. Mark it as an assumption because we're given it. And in our second line, we would just write P arrow T. Same rule as before. This is our left side. Actually, those should be circles based on what I gave you up above, but colors also help. So right side goes there. And then if I want to change it to P and T, or P and Q, sorry, then same proof. Just taking the other side instead. So that's our ampersand out. So our new rule for the week is wedge in, and it's probably the easiest rule. It's just, it says that from something, wedge in anything that you want. So thinking of this statement in such a way, I have a pen in my hand that I'm writing on the tablet with. So I could say I either have a pen or I have a spaceship. And so it's a true statement because I do have a pen. It doesn't matter whether or not I have a spaceship. And the same thing works for the proof structure. It says as long as you have something in your proof, you can wedge in anything you want because obviously it's going to meet the truth conditions necessary for a disjunction or a wedge statement. So from something, wedge in anything that you want. And then also it can go in any order. So same thing. So say if I were to give you this, you would just write your one premise, and then you would just wedge in the Q. You would cite one, wedge in, one just like that. And just to drive the point home, say if I were to put something as, obscure as that, it's the same exact proof because all it says is either P or all this junk here on the right side. So as long as I have a P, I can put whatever I want next to it. Extended that line just a little bit too far, but I can put whatever I want next to it. And so, also, the order doesn't matter, so I should do this real quick before I show you the more convoluted looking one that's just the same exact proof. So say if I were to give you this, it's the same thing as before, just written in a different order. Because it doesn't matter which side you introduce the term next to the P on. As long as you got one term, you can wedge in anything you want on either side of it. So you could take something that looks really difficult and could be very simple. So say if I were to give you P and Q, therefore P and Q wedge. Let's do not P arrow T and S. Something like that. It's the same exact proof as before. So I have this term P and Q in my assumptions. And all it's saying is I'm taking this P and Q and I'm slapping something next to it with a wedge. So whenever you have a wedge in a proof and it's say like it's bound up to a conditional statement on the left hand side, say there's a wedge that's an antecedent, and you have one of those terms, well then you could build the antecedent and go ahead and kick out the consequent in those conditional statements. And as we do practice problems, that will be one of the ones that we run into quite often. So but this is the wedge in rule. I'm going to show you another just a practice problem here on this slide, and then we'll get into practice problems that use all four of these rules in conjunction and in different varieties of ways. So let's just do something like I just mentioned here on the previous slide, which say is this. So we have two premises, P wedge Q, arrow T. It's an assumption. P, also an assumption that we have. 1 and 2, we associate them with the assumptions with the line numbers they're introduced. Now, like I just said, we've got this conditional statement. And to make use of a conditional statement, we have to get the antecedent or the left side. We don't have that, but we can build it since we have one of the terms here, P. So from P, we can build P or Q. Remember, we got number 2, so, or sorry, 2, so it goes here. Now we have the left side of our conditional statement, and then we can toss that left side into here, kick out our T down here. And so from 1 and 3, we get arrow out, 1 and 3, and that's our proof. That was what we were going for. Now let's try something where we have the wedge in the conclusion. So say we have P and Q, Q, let's make it Q arrow T, therefore T or L. So same process as we do with all of our proofs, just list some numbers, write our assumptions. That's the first step. Now, we should look at our conclusion. Our conclusion is a wedge. So that's telling us we need to find one of these two sides. If we can find either T or L, then we'll go ahead and slap them together or slap the other one onto it using wedge introduction. Looking at our assumptions, the only one of those letters we have is T. So we already know that we're going to look to get T out, and then we can use the wedge introduction to put the L next to it. So that T is bound up with this conditional statement. We don't have its left side, but its left side is here. So in our third, we can get the Q out using 1 and out. Remember, we could write the P here. We're not going to need it, but that's totally fine. We could write this. Again, we're not going to need this later, but you can write it because our 1 and out rule says take either one of the sides. So now that we have our Q, we can toss it in this conditional. We can get the T by itself like that. And so that's going to be from 2 and 3, arrow out, 2 and 3, have 1 and 2 next to it. And then since we found our T, we can wedge in the L just like that. And that is our proof. So wedge in is just something like if you have a wedge as your conclusion, then you're saying I just need one of these sides and then I'll wedge in the other. If you find a wedge somewhere in the proof, mainly when you see something like a conditional statement bound up with a wedge, that might be an indication that you're going to have to build that wedge. Again, finding one of those sides and then wedging in the other side to sort of deconstruct the conditional statement. But those are some pretty basic proofs for it. The next lectures will just be practice problems in which we're taking all 4 of these rules that we have now and working with them to solve the sequences that are in the problem sets.